Welcome to a very special explainer. Think of this as a grade makeover kitchen audit for your Cambridge Mathematics 9709 exams. Today, we are dissecting a true heavyweight in the syllabus, trigonometry and specifically double angle formulae. Mastery here is absolutely crucial. Why? Because these formulas pop up in almost every single examination series. They are literally the gatekeepers to those top marks. But we constantly see incredibly bright students serving up messy, failing responses and dropping points unnecessarily. Well, today, we are going to fix that.
So, why do students find multi-stage analysis and method marks so incredibly hard? Let's look at the sour ingredients of a bad response. Picture two of my past students. We've got Alex, who overcomplicates the recipe by just throwing in unanalyzed facts. And we've got Sam, who completely rushes the writing process and skips crucial structural steps. They both walk into the exam room knowing their identities backward and forward, but walk out with a C instead of an A star. It almost always comes down to missing those elusive method marks. Cambridge doesn't just care about your final destination. They critically evaluate the journey you took to get there.
To demystify this grading process, we are opening up the examiner's playbook. Here is our recipe for today. Number 1, core principles. Number 2, the procedural framework. Number 3, critical analysis levels. And finally, number 4, examiner warnings directly from the source. Let's get cooking.
Section 1. Core Principles.
Before you write down a single equation, you have to understand the academic benchmarks Cambridge is actually looking for. The assessment framework strongly prioritizes analytical depth and structured reasoning over just superficial breadth. It is nowhere near enough to simply memorize that sine 2 theta equals 2 sine theta cosine theta. That kind of superficial memory totally fails when Cambridge throws you into an unfamiliar multi-layered context. Alex makes this mistake all the time, just listing facts without connecting them. Cambridge wants logical, structurally sound reasoning from the very first line of your proof all the way to the last.
Section 2. The procedural framework.
Okay, let's step into the kitchen and recook a messy response into a perfect mark answer. But first, if you want to stop serving up average grades and unlock the secret recipe for an A star, subscribe to Ace the Exams at Ace the Exams right now and hit that notification bell. All right, let's get back to it. Here is the standardized 5-step sequence you need. Step 1, identify key elements, like which identity is hiding in this complex fraction. Step 2, apply relevant principles using a correct substitution. Step 3, execute the analysis with crystal clear working. Step 4, verify your results against the given domain. And Step 5, present it in the appropriate format. Following this exact sequence forces you to think exactly like an examiner.
Let's zoom in on Step 3 for a second. Clear working. This is where Sam usually completely ruins the score by hitting a massive roadblock connecting the mathematical steps. To rescue the flow of your proof, think of the peel structure. Point out the identity, provide evidence via substitution, explain your algebraic steps clearly, and link it back to the required format. In double-angle questions, marks are heavily awarded for the process itself. If you skip steps in your head, like instantly converting cosine 2 theta without explicitly showing that you chose the 2 cosine squared theta minus 1 variation, and then you make a tiny arithmetic error, boom, you lose both the final answer mark and the method marks. The examiner literally cannot see your logic. Your working is your proof of understanding, period.
Section 3. Critical analysis levels.
Now it's time for an interactive taste test. Imagine a 60-second countdown timer on your screen right now as we try to find the winning argument point. Look at how this builds across the assessment framework. Level 1 is descriptive, just extracting the right identity. Level 2 is analytical, interpreting relationships to simplify an equation. But Level 3, evaluative, that is where the magic happens. In a pure math context, this means justifying a solution, evaluating domain limitations, or actively choosing the most efficient cosine double angle variation. For example, knowing to choose 1 minus 2 sine squared theta specifically to cancel out a tricky sine term and avoid messy algebra. Evaluating those alternatives is what pushes your grade right up into that top band.
Section 4. Examiner Warnings. We have pulled the top mistakes directly from the Cambridge Principal Examiner reports. Think of this next challenge as finding the hidden critical error in a paragraph that instantly forfeits 5 whole marks. Look at this quote. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. Generic math completely ruins otherwise sound logic. You might perfectly manipulate a double angle formula,
But if the question asks about the maximum height of a wave in a practical modeling context, and you just write x equals 0.5 without linking it back to the actual wave, you are leaving massive points on the table. Context is king.
So the crucial point here is that you must actively guard against 3 completely preventable errors. First, answers that are too vague, meaning you lack specific algebraic detail in your substitutions. Second, forgetting your format and presentation. Seriously, do not leave an angle in degrees when the domain was clearly given in radians. And third, as we just saw, failing to be specific to the context. These mistakes cost really smart students easy points every single year.
For our 5-star presentation, I want to give you a memory hack to make sure you never fall into these traps. It's based on that standardized sequence we discussed earlier. Just remember, IAEVP. Identify, apply, execute, verify, present. Before you drop your pen on a massive 7-mark trigonometry question, run through that acronym. Did you identify the right formula? Did you execute with clear working? Did you verify the domain? Did you present it in the right format?
Which leaves us with one final, incredibly important question. When you sit down for your 9709 paper, will your next answer be generic, risking all those crucial method marks? Or will it be guaranteed, backed by flawless, structured reasoning? Take this 5-star playbook, apply the IAEVP sequence to a huge stack of past papers, and watch your grades completely transform. Remember our 3 golden rules. Prioritize depth over breadth, explicitly show your working to secure method marks, and always link your final answer back to the context. Don't forget to subscribe to Ace the Exams at Ace the Exams, turn on those notifications, and comment below with a specific subject and level you find the hardest. Keep learning, keep practicing, and I will see you in the next explainer.